Welcome to homework.
Our question says that starting from equation 15a shows that the Doppler shift in wavelength is delta lambda over lambda, which is equal to the velocity divided by the speed of light, or v over c. And they said to do this by using the fact that v is smaller than c. So the velocity is much light. Starting from the equation lambda equals lambda naught times the square root of c plus v over c minus v. And the source and observer are moving away from each other. Okay, so we'll start with that equation we were told to start with, which is lambda is equal to lambda naught times the square root of the ratio of c plus v to c minus v. Okay, so if we divide the values in the square root by c over c, so if you divide the top part by 1 over c and divide the bottom part by 1 over c, then this is going to be equal to, you can rewrite this as lambda naught times the square root. Oh, let's write it down a little bit so we have some room. Lambda naught times the square root of 1 plus v over c divided by 1 minus v over c. So then if you multiplied back through by c over c, then you get back to what you started with. Okay, so now we're going to multiply this equation by the square root of 1 plus v over c divided by 1 plus v over c, since that's just 1. So we're multiplying this by 1. So we're not changing the value of the relationship, so that's allowed. So this gives us lambda naught times the square root of 1 plus v over c times 1 plus v over c divided by 1 minus v over c times 1 plus v over c. Okay, so on the top, you have, in the numerator, you're going to have 1 plus v over c times 1 plus v over c, which is 1 plus v over c squared, and that's square rooted, so the square goes away, so you'll end up with just 1 plus v over c. So you have lambda naught times 1 plus v over c. Okay, and then for the denominator, where you have 1 minus v over c times 1 plus v over c. Okay, so this is going to be 1 over the square root of 1 over, and then we're going to carry out this this operation. So multiply the 1 through, so 1 times 1 is 1, 1 times v over c is v over c, and then you multiply the v over c through. So minus v over c times 1 is minus v over c. So the v over c and the minus v over c are going to cancel. And then you'll have minus v over c times plus v over c, which is minus v squared over c squared. So you end up with 1 minus c squared. Okay. The fact that we were given where v is much smaller than the speed of light. And since v is much smaller than the speed of light, this v squared over c squared value is going to be extremely small, close enough to 0 that it can just be ignored. So we're going to say this goes to 0. So that is going to be the square root of 1 over 1, which is just 1. So now our equation is lambda is approximately, since we just made the assumption that v is much less than c, it's approximately lambda naught times 1 plus v over c. Okay, so we're just going to multiply that lambda naught through. So this is going to be equal to lambda naught plus lambda naught v over c. Okay, so we were asked to show that delta lambda over lambda is equal to v over c. But delta lambda is your final lambda minus your initial lambda value, or lambda minus lambda naught. So if you subtract the lambda naught over, let's do this on a new page, you're going to have lambda minus lambda naught is equal to lambda naught times v over c. So then we'll divide by the lambda naught value, and we'll also recognize that lambda minus lambda naught is delta lambda. So you have delta lambda divided by lambda naught is equal to V over C. And that was the expression that we were asked to show. So we just proved it. You can box that in as our solution.